Okay, today we're looking at graphing quadratic equations. So we are going to, if you read the notes here, it says we need to transform the equation from standard form to vertex form, which is just what we've been doing the last couple of days, and then we're going to transfer that onto the graph. So the first thing we want to do is transform the standard equation into vertex form. So y equals, we've got x squared minus 8x. Now I showed you guys a couple of ways how to do this in class. All right, so this is just one of the ways where both of our blanks are on the same side of the equation. I'm able to fill in my blanks now because I have a 1 in front of my x squared. So I take half of my negative 8, which is negative 4, and I square that. So negative 4, and that's what's also going to go in here. The shortcut to factoring, half of negative 8 is negative 4. When I square that, that's negative 4 times negative 4 is positive 16. Now, since they're on the same side of the equation, this has to be a negative 16. So I've already taken the shortcut here to factoring this parenthesis. Now I just need to combine these like terms. 18 minus 16 is positive 2. Okay, so my vertex, as we answered on the homework previously, my vertex is always the h and the k. So here, opposite of what your x says, so this is going to be a positive 4, and then the y value there is what it says it is, so positive 4, positive 2. So there's our vertex, positive 4, positive 2. Okay. Now, remember, we have our table. Okay, this is a quadratic, so anytime we have our x squared, our original parent function, we had x values of negative 2, negative 1, 0, 1, and 2. And so when we squared those, you had a 4, a 1, a 0, a 1, and a 4. Okay, that was the original parent function coordinates. But what we have to do here is we have to take our a value, which here it's a 1, we multiply the a value times all of the original y values. So if we multiply all these guys times 1, times 1, times 1, times 1, times 1, that's going to give me my new y values. Here it actually turns out it doesn't change anything. 4 times 1 is still a 4. 1 times 1 is still a 1. 0 times 1 is still a 0. 1 times 1 is still a 1, 4 times 1 is still a 4. So we always start from our vertex, which we've plotted that coordinate, 4, 2, and we're going to go 2 to the left of the vertex, and we're going to go up 4 on the y-axis. So 2 spaces left, 1, 2, 3, and up 4. We're going to go 1 space left and up 1, over 1, up 1. We're going to go 0, 0, that is the vertex. Left and right, nowhere. Up and down, nowhere. So we're going to go 1 space right now, since it's a positive x value. 1 space right and up 1. And then we're also going to go 2 spaces to the right and up 4, always starting from the vertex. 2 spaces right, 1, 2, 3, up 4. Okay, so there we have graphed the quadratic. And we should have known that this guy's going to open upwards because my a value here is a positive 1. Okay, so we zoom out and look at the next problem. We're going to do the same thing. We are going to solve, we're going to rewrite this from standard form to vertex form. So I've got 2x squared plus 4x. There's my blank. Move my plus 1 to the back, and he needs a blank as well. Here I cannot fill in the blank yet because I have a 2 in front of the x squared, so I've got to take that GCF out. Okay, if I take a 2 out, what's left over? I've got an x squared left over. 4 divided by 2 is 2 left over there. Nothing else changes. Now I'm ready to fill in the blank. So when I take half my 2, let's go ahead and use the shortcut here. Half the 2 is a positive 1. Don't forget the GCF here as well. Half the 2 is a 1, but then you have to square that. 1 times 1 is 1. But that's not what goes over here. We have to distribute now. 1 times 2. 1 times 2 is 2. So the opposite of that goes in the other parenthesis, negative 2. So now when I combine these like terms, 1 minus 2 is negative 1. So here my vertex is always the opposite, negative 1. And this one's not the opposite, so negative 1 is my vertex. Negative 1, negative 1. Plot that coordinate. Okay, so again, you look at your original table, okay, your original y values. X's and Y's. So I had -2, -1, 0, 1, and 2. That was a 4, 1, 0, 1, 4. So we take our A value here, which is a +2 this time, and we multiply that by all the original Y values. So we're going to multiply all these Y values times 2, times 2, times 2, times 2, times 2, and that's going to give me my new Y values. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is still 0. 1 times 2 is 2. 4 times 2 is 8. So now from my new vertex, I'm going to go left 2, since that's the X value, -2, left 2, and I'm going to go up 8. Left 2, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go left 1, and I'm going to go up 2. Left 1, up 2. I'm going to go 0, 0. That is the vertex. I'm going to go right 1, up 2. And I'm going to go right 2, up 8. Right 2, 1, 2, 3, 4, 5, 6, 7, 8. And there we've graphed that quadratic. Again, we knew it was going to open upwards because my A value is a positive. Oh, also the axis of symmetry, if we were going to cut this guy in half, right, it goes right through the -1 on the x-axis. X equals -1. The previous problem, if we were going to cut that one in half, goes right through the 4 on the x-axis. So we'd say x equals 4, the x value of the vertex. Okay, so that's transforming it from standard form to vertex form. All right, now here, if we're not transforming it, we want to leave it in standard form. Okay, leave the equation in standard form. We need to find the vertex. So our vertex is going to be -b divided by 2a. That's going to be the x value of my vertex, or my h. The vertex is h and k, all right, which is really the x and the y. So to find the x, it's -b over 2a. Remember, we need to identify these guys. A, b, c. The a is a half. The b is a -2. The c, my constant, is a 1. So if you rewrite this formula, -b divided by 2a, use parentheses. Okay, for us, -b, the b value is a -2, and then over 2 times a. A is a half. Negative times -2 is +2. And 2 times a half is just 1. So 2 divided by 1 is just 2. Okay, that is your h value of your vertex. The h value, or the h is the same thing as the x value of your vertex, 2. Now, how do you find the y value of your vertex? Well, take that 2, since I know the x, take it and plug it back in. Okay, so plug it back into the original equation. So I'm going to use my calculator here for that. So I've got a 1/2 times x squared, so times 2 squared, minus 2 times x, so 2 times 2, minus 1. Okay, and I come up with a -3. When I plug all that in, I plug my x values are 2's, I come up with a -3. So there's my vertex, 2, -3. +2, -3. There's the vertex. Okay, now remember those original coordinates, those original x, y values. -2, -1, 0, 1, and 2. It was 4, 1, 0, 1, 4. Okay, this time I'm going to multiply by my a values again. My a value here is a half. So if I multiply all these by a half, every y value gets multiplied by a half. So 4 times a half, half of 4, that's 2. 1 times a half, half of 1, that's a half. 0 times a half is 0. 1 times a half is a half. And 4 times a half, half of 4, is 2. So now from this vertex, I'm going to go left 2, up 2. Left 2, up 2. I'm going to go to left 1 and up a half a space. Left 1 and up a half a space. Then I'm going to go right 1 up a half a space. And I'm going to go right 2 up 2. Okay, and there is that quadratic. Okay, a little bit different there. Okay, leave it in standard form. Identify your A, your B, and your C. Use -b over 2a. That tells you the x value. Plug that x value back into the equation to find his y value.